Hey guys, welcome back. It's Showcasing Stupidity. We're doing episode number 4. Today's gonna be kind of weird. It's not exactly showcasing actual stupidity. I actually got a comment on my first video, excuse me, from last year, and it's a really cool comment, and it asked a couple of really good questions, and I read it and decided I think it's going to be a really good opportunity for us to define some terms, so that whenever I use so that you know what meaning I'm applying with the words I use in my videos, especially since there's some of the videos that I'm mapping out and having coming up in the future for next year are going to be gearing more towards debunking pseudoscience and debunking science deniers and all that kind of good stuff, because I'm a physics geek. You know, I accept the scientific method, and I think it's something that entirely too many people, both in real life and especially on the internet, really need a tutorial on, because they just don't know. They don't know what it is. They don't know how to use it to test hypotheses and ideas and all that good stuff, and I'll get into that later. But anyway, get right into the message real quick. And I'm sorry, I suck at editing. Oh my god, you would think the quality of videos would have gotten better by now, but no, they haven't, because I'm still ad-libbing and still dealing with the pauses and the obvious, low production value things that I simply suck at editing out, and it basically boils down to I really don't have the patience for it. It's one of the reasons my videos take so damn long, is because I'll make a video and I'll try to edit it to increase the production value of it, and in the process I'll just jack up the videos so bad that I ended up scrapping it and just throwing together a quick ad-lib. But anyway, just be aware. I know production values suck. Oh well. Hopefully I'll get better at it, but I just really, oh god, I hate editing. Excuse me. So let's do this real quick. All right. I'm not going to give the guy's name, and the reason I had that little disclaimer about editing is part of the editing would be to take this message and put it up in the video so that you can read along with me as I'm reading, if you wish, and thus show that yeah, you're watching my videos and I'm being verbatim. You know what I mean? I'm not adding and subtracting and erecting logical fallacies everywhere. But yeah, so let's get on into this. Hey, let's see. He says, "Hello, I'm sorry to leave this here, but YouTube no longer has the private message function, and I don't want to attract lunatics." Have you forgotten what channel you're at? It's okay, but anyway, I've heard people has this notion that science cannot bring proof to light. I'm not exactly sure what you mean by that. Mainly because I don't, in a scientific context, I don't think you're using the words correctly. So it's now later on in the message, yeah, I kind of get a good idea of what you're actually trying to say. Um, and by the way, this person is extraordinarily polite. And they ask a really, really good question, and it's a question that in real life I've heard being asked so often, and I get to the point where I just start going la 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 la, because it's either that or start an hour-long debate with someone simply because of their semantics. So, but let's define a few terms here, so that we're all on the same page. When I use certain words when describing or discussing scientific concepts, in science you have to be very, very particular about what language you use to get your point across or describe what you're doing or what you're trying to say. And as such, there are certain words that are used colloquially, and unfortunately they don't really translate to their scientific meanings very well. Excellent example is colloquial theory versus scientific theory. They're not the same damn thing. And Lord have mercy if I had a shitload of arguments about that one. Excuse me. So I'm getting a little bit over some sinus and junk like that, and still smoking, but oh well, what you gonna do? But yeah, let's define a few terms here. I'll tell you what. Let me back up a little bit. Let me go ahead and just read. I'll go ahead and just finish reading, and then we'll go back and we'll respond to the message in a more concise way. All right. Sorry. Now, I worked on a chemical lab for quite some time, and most of our investigation had the purpose of finding proof for cool hypotheses. I think you mean hypotheses. The standard definition of proving is prove. Transitive. To use facts, evidence, etc. to show that something is true. So what's the deal? Is it because a proof should be eternally valid? If so, I don't think anything that fills the description outside. I don't think anything fills that description outside of life and death. Well, all right. Let's pick this apart, for a few minutes. And let me say again, this commenter was extremely polite. I mean absolutely no disrespect by responding to it in a video. That's why I said at the beginning, welcome back, welcome to Showcasing Stupidity, but this isn't really showcasing stupidity. This is more, I just really, really like this comment, and I really wanted to respond to it in a positive way. But, alright, so let's define a few terms here. Fact. A fact is a point of data that is either not in dispute or indisputable. Okay? The sky is blue. For our purposes, that's true. That is a point of data that is indisputable or not in dispute. Now, when dealing with science, science does not deal in proofs. Okay, mathematics does. Mathematics are literally the only academic field that deal with proofs. Science deals specifically with evidence. Evidence is not proof. Evidence is simply a collection of facts that support the conclusion you're drawing. One of the really cool things about the scientific method is step 2 is form a hypothesis. And this hypothesis is literally your best estimate of how or why something is happening, like some kind of observable phenomena. But in science, you'll never be able to prove that hypothesis. You can falsify the hell out of it. Matter of fact, any and all real hypotheses have that characteristic by design. They have to be falsifiable. And this is the main reason why science doesn't deal with proof, because the connotations of proof, of the word proof I should say, in an academic sense, as I'm trying to, in a very long and drawn out way, trying to explain, is I think of it as kind of on the same level as a scientific law. Mainly because if you have proof of something, then you have an unchangeable conclusion. And what I mean by that is, if new evidence comes to light later down the road, if you've based your scientific knowledge on proofs, that is anathema to accepting new evidence. That's why science does not deal in proofs. Now, mathematics does, because mathematics don't change. They are what they are, or let me rephrase that. Mathematics hasn't changed in any dramatic way since Isaac Newton. And that's because he and another cat in Germany, another mathematician in Germany, both simultaneously came up with the concept of calculus. So, to the best of my knowledge, that's the last time that there was a dramatic shift in mathematical principles, because there certainly haven't been any in the last 100 years, or 150 years. So, yeah, giving proofs in math is fine. Math doesn't change. Math doesn't allow for new evidence. Because once you have a mathematical proof, there's no way to change that. It becomes a proof when that particular mathematical formula or equation stands up to literally every situation you can feasibly put it in. That's when it becomes a proof. So yeah, with science we have to be able to shift and change on the fly. We have to be able to accept new evidence, and that means that we can't go and run with proofs in science. Right? We can only do evidence. Now, he uses I'm not sure if it's I don't think I'd call it the standard definition. It's certainly one of the definitions. The only problem is it's not the definition that's applied to science. It's talking about proof. Now, in science, you use evidence to support the conclusion you've drawn. And the scientific method has these wonderful, wonderful fail-safes built in. They're self-correcting. You don't have to... If you do it right, if you do it correctly, then any problems that you encounter with evidence that supports your conclusion or falsifies your conclusion, it's going to pop up to somebody. Because the only way you get any recognition in science is whenever you submit yourself to peer review. And scientists are fucking evil. They really are some of the most backstabbing professionals in history. These science is all about publish or perish, and by that I mean if you want to be successful as a scientist, you better come up with a really good, interesting idea before anybody else does, so that you can get all the credit. Flip side of that is if you come up with a really good idea and the way you collected evidence to support your conclusion is somehow suspect or deemed wrong on some level, it fails to meet the criteria of some step of the scientific method, that failure follows you forever, buddy. Sorry. It sucks, but that's the way it goes, man. You know what I mean? Alright. So, yeah, we can use evidence to support a conclusion. In math, we can use, in mathematics, we use known theorems and laws, or occasionally we'll find new laws or discover new create new theorems in mathematics. But we take these things and build a proof so that we can solve the equation. Solve for x. What the hell is x? We don't know. It doesn't matter. Just solve for it. That's your mathematical education tax dollars at work, folks. It's awesome. I love it. Anyway, so he asked, what is the deal? Is it because proof should be eternally valid? No. Well, yeah, proof, but I'm getting away from proof. I'm done discussing that. I'm going back to discussing evidence now. In science, no, evidence is never eternal. Or I should say, scientific evidence does not need to be eternally true. It does need to stay internally consistent, though. A wonderful example of this is the theory of gravity. Well, Newton came up with that bad boy in the late 1600s. And he actually didn't come up with the theory of gravity. He came up with the laws of gravitational attraction. But there were some gaping, gigantic holes in his math. Mainly because he wasn't able to think outside the box enough to realize how to fix the problem. Main one being the biggest problem with Newtonian gravity, and he didn't even worry about it. He just said, you know what? I don't care. It doesn't matter because the laws work. His 3 laws of motion and the gravitational law of attraction. But Newton's ideas completely failed to answer a simple question: how does the Earth know where the sun is in order to go around it? Okay, follow me? Cool beans. What would happen if you moved the sun? What would happen to the Earth's orbit? Isaac Newton said, I don't know. I'm not going to worry about it because, hey, my laws work. And they did. Now you skip ahead 200 years and you get to Albert Einstein and his 2 theories of relativity. You've got special relativity and you've got general relativity. Special relativity is its own little acid trip sidebar. I might come back to that one later. I don't know. But general relativity answered the question that Newton couldn't. Okay? Or basically that mass sitting in space is, think of a trampoline. Put a bowling ball in the center. Alright, the trampoline warps, right? Okay. And gravity is analogous to the edges of the trampoline pushing the space into that bending that the heavy mass creates in space-time. Now, Einstein's theories, and the really cool thing is he got a Nobel Prize in science, but never got it for relativity. He got it for really cool things he discovered about light. But having said that, cosmologists, physicists, astronomers, all these wonderful folks, they have spent the last almost 120 years trying to debunk Einstein's theory. They never have. Now, his theory isn't perfect, but his theory supplanted Newton's. It replaced Newton's. Now, that doesn't mean that we just discarded everything Newton discovered, because that's not how scientific theories evolve. Right? You can't come up with it. You can't come up with an acceptable new theory unless the new theory explains everything that was explained in the theory it's replacing, the old one, plus answers things that the old theory couldn't. If the new theory doesn't meet those two criteria, then it'll never become a theory. It won't. It just will not do it. The scientific method does not allow that. Crap, sorry. Lit my damn finger on fire. Alright, so now should a proof be eternally valid? In math, yes. In science, no, because science doesn't deal with proof. Science deals with evidence. If so, I don't think anything fills that description outside of life and death. If you're talking about eternal, how's he phrase it? If you're talking about eternal validation, I'm not really even sure that life and death would necessarily be either eternal or eternally valid. And my philosophy on that gets a little complicated and warped, and this video is already long enough, so I'll come back to that in another video if you guys want. Now, the evidence for life and the evidence for the phenomenon of life and death has to stay internally consistent, and as far as we know, it does. So, in that respect, then yes, the evidence there needs to stay the same under every applicable instance or process or what have you. Now, as far as this idea, being describing anything other than life and death, I think you're selling yourself short. And I say that because deep questions like this, I find, tend to be really, really aggravating, self-aggravating, I should say, if you can't find an internally consistent manner of explaining that position. right off the top of my head, I can't think of any. I can't think of anything I could point to say without doubt and without exception that the evidence for life is eternally valid. This is why we define our terms. That makes no sense at all. When you look at the phrase, when you look at the sentence like that, it's complete nonsense. But when we're using our correct terms, the internal evidence or internally consistent evidence supports life, or rather supports what we know about life. That in and of itself makes a ton more sense than the eternal validation mode of thinking. But anyway, sir, I'm going to go ahead and wrap this up, sir. I do appreciate your comment. Thank you, guys. Subscribe, click like, leave some comments down there. I'm loving this kind of crap. I need more people to jump on here on my other videos. Throw some comments at me, man. Let's chit chat. Just remember the rules. Don't come at me with stupid. I'm gonna hurt your feelings. God bless you guys. Love y'all. Oh, a late Merry Christmas and an early Happy New Year. Love you guys, and I will see y'all in the next one.